Shakar Pandey, ComEd, great to see you. Thanks for joining me.
Good to see you, John.
So, I've been really looking forward to having this conversation with you, and we've been going back and forth for probably a few months now in really unpacking the journey of a utility with distributed energy resource management systems because there are some real deployments out there that are installed and working, and then there's a whole lot of hot air that I think surrounds this space and this technology, maybe because it can be so versatile and is so important to many of the things we're trying to accomplish with the energy transition. But I love this show because it allows me the venue to bring a little bit of a finer point and clarity to otherwise buzzy things. And I think DERMS squarely fits into that category. Shakar, before we get going, can you explain a little bit about your background and your role at ComEd? And I know you're involved in IEEE and a million other different things. So I'd love for the audience to get to know you like I do.
Sounds good. Well, for the audience, good morning, good afternoon, depending upon when you'll be listening to this. I am senior manager of ComEd's DER planning and engineering team. I have a team of about 20 people responsible for DER interconnection studies, non-words alternative solutions, value of DER, which is an ongoing investigation actually into the state to figure out the value of DERs that it provides to the distribution grid. My team also leads ADMS technical activities, to have it connected and roll out at ComEd. We lead, like John mentioned, the DERMS demonstration projects, right, and trying to scale it up into DERMS expansion. We also publish our hosting capacity maps, and now we are figuring out what do we mean by dynamic hosting capacity, do we mean by flexible interconnection. So having that conversations basically. My team also leads for 2222, technical aspects of it, right? And the team constantly collaborates with the stakeholders and customers to ensure process enhancements needed to enter this DER world basically. So that's what mostly the team does. I don't do much. I work with the team. My main job is to make sure that all the stakeholders are aligned, where the policy is going. How do I distill that policy, bring it to a technical reality? How do we move forward some of the technicalities that we figure out, things that can be done and that cannot be done, right? There is a difference between your wish and the reality that there can be. So I'm kind of right in the middle personally. As far as before ComEd, I used to work for a couple of national labs: Pacific Northwest National Lab, National Renewable Energy Lab. I have my master's and PhD from Washington State University Pullman. Right now, I'm pursuing my MBA from Chicago Booth School of Business. At the same time, I lead, at IEEE, it's electrical and energy electronic society basically. So I lead there. I'm the chair of IEEE Distribution Resiliency Task Force. So we are trying to come up with standards to measure or quantify the distribution resiliency, distribution system resiliency. Basically, when storm comes, you lose a lot of customers. How do you measure how less customers are you losing as the time progresses, and how do you measure how effective your restoration was? Things of that nature. I think we should have more conversation on that, John. I think we've talked about it. Other than that, I'm also the chair of IEEE Grid Flexibility Task Force that deals a lot with topics like DERs. What does it mean for the grid? Does the grid need DER? Do DERs need grid and whatnot? So we have published some reports around it, and now I'm leading the virtual power plant, basically white paper. So trying to get all the utilities, not only North America but Australia, New Zealand, other places, on the same page to figure out, okay, what is the definition of VPP? What can it do? What it cannot do, and things of that nature. So that's another aspect of my non-daytime job basically.
So the TLDR for all of that is you're pretty obsessed with this shit.
Yes. I mean, this is the only thing that I know. You can say that. I don't know
Yeah.
anything else.
Well, so here's the thing, and I've said this a couple of times on this show. When the technical people start going out and getting MBAs and law degrees, that's when everyone else should get really freaking nervous. Because Shakar is already one of those guys, pretty young guy, that is a mainstay at Distributech, the event that I help lead. And all over IEEE, you're chair of these very, very important efforts around resiliency and measuring resiliency. And I think that it'll be interesting to see where you go with an MBA. Maybe you'll go for that law degree next, and we'll see you in a C-suite somewhere in no time. That's my forecast for you.
I'm done with degrees. My wife won't let me hang my degrees on the wall because she has one less, and she's like, no. So, I
See,
have to stop now.
I'm in the opposite position where my wife has one more, and I never hear the end of it. So when she ever needs me to do something for her, I go, wow, the master's degree didn't cover that, So I got to get those in from time to time, or I'm just a state school comms guy. So anyway, that is a great precursor to this conversation, in which I'm going to talk about a lot of technical things and try not to sound stupid as I grapple with these concepts. So we're talking again about distributed energy resource management systems. We'll call them DERMS from here on out. For those that don't work inside a utility or are not familiar with the tech stack when it comes to advanced distribution operations, can you, in plain terms, before we dive into the meat of this, walk us through that stack and maybe some of the core functionality of each piece of software that a utility is primarily using for grid ops, maybe working through, SCADA and ADMS and up to DERMS, and what separates them?
Yeah, I mean, traditionally, and again, I work mostly on the distribution side, right? So there is a whole world of transmission side software, right? That people use and whatnot. It has NERC for compliance and whatever. But let's focus a little bit on the distribution side, because we are talking about distributed energy resources management systems eventually, right? So yes, we do have our SCADA system, right? Supervisory control and data acquisition system. I still remember it, the mouthful. But what it does is that's basically your eyes and ears and brains to some extent, right? Of how things were happening, and being monitored and controlled. What it does is that it has your system modeled into, let's say, one giant database, for example, right? And it will get measurements out from the field to figure out what is the loading on the line, what is the loading on the transformer, and it comes every 4 seconds, for example, right? They were not typically very time stamped. So in and about 1 to 4 seconds, you would get a measurement, and there would be some state estimation calculation that would go on that would figure out the state of the system. Based on that, there would be screens and control system and centers. It still is, and it's still very prominent, and people are working on it. And then the operators would see what's going on into the field, and they'll take the desired control as needed, right? So that's the typical work of SCADA system, right? Supervisory control. Now we are trying to move towards advanced distribution management system, right? SCADA. Taking the SCADA into the ADMS is the first step, basically, right? But it's the reason why it's called advanced is it's just not only measurement and aiding the operator to control it. It has advanced applications, such as fault location identification, right? It will have integration with all the AMI meters that you have to locate the fault, soon enough, right? It will have functionalities to get, DER data, how it's operating and whatnot into the system, right? There is a concept of FLISR. It's called as fault location identification and service restoration, right? These are advanced applications that ADMS would enable, which otherwise SCADA could not enable, right? It has the ability to crunch a lot of input faster than what we used to see in SCADA. So that's the ADMS side of it. And I feel like every utility is working on their version of ADMS. In theory, there's a lot of articles, literature out there that you can read upon to figure out, okay, what is ADMS? My personal feel is that it's gonna be first mimicking what you have in SCADA, right? So just porting over from SCADA to ADMS, and then from there on, providing a platform to actually build upon it and see what application makes sense for which utility, right? So that's what I think the journey would be. If you go out there, you will see a laundry list of applications, and I don't know if it's all of them are going to be a reality anytime soon. But that's where we are working towards, right? But therein comes, and DERMS, DER management system, was supposed to be one aspect of ADMS, right? However, in some sense, we've pulled it forward, right? So, first you have to deploy ADMS, develop some of the basic functionality, then would come a DERMS. Right now, we have pulled it forward because this use case of connecting DERs faster, driven by policy, by customer interest, and whatnot, has really accelerated the need for DERMS. And when we talk about more, what DERMS is, we can go into more details. But that's where DERMS sit right now, right? So in kind of with SCADA, ADMS, parallelly exists a DERMS system now at certain utilities, at least at ComEd it does, right? And we are trying to, resolve some of the use cases that's coming for customer needs using the DERMS system. I see a future in which, DERMS and ADMS either could be integrated into one piece of software, or it could be, talking in a very close proximity, sharing the data within one another and whatnot, right? That architecture we'll have to figure it out as we go through. But that's the distinction between SCADA, ADMS, and DERMS in somewhat layman's term.
No, that was really helpful. So, and to break that down, then SCADA is eyes and ears and minimal control. ADMS takes it a step further in the control arena and also gives you better visibility into your data. And I think there's some forecasting involved there. And then DERMS, you're really getting into the control piece even more, and trying to create a dynamic grid that lives and breathes with both the consumer of power and the power generation the contributors. And the other piece of DERMS, which I don't even know if we're going to get into all the segments of DERMS, which I had to learn with time that it was so modular in that you've got grid edge DERMS that are working on a lot of energy efficiency and demand response and virtual power plants. Then you've got grid ops, which is like the big task, which is a little bit more ambitious, where a utility can be that central force and repository for all the data and the controls and that dynamic movement and so on and so forth. Well, let's drill into ComEd's use case, at least the initial use case, which I'm assuming is going to expand, and you can get into that with time. When did you all start determining that the ADMS was not going to be enough and we need a new solution, something like a DERMS? When and why, I guess, is the question.
As I said right earlier, that ADMS has its timeline, right? And it's such a gigantic project to take all of ComEd's SCADA system to first port into something new and then build on from there. Whereas, the way DERMS came about is that there is one situation where we wanted to connect, more DERs, but the solution was to actually rebuild the grid in that particular location, if that were to be a reality, right? And I think that is where DERMS comes in, and there is no way that ADMS could give us that timeline to meet the customer needs, right? So I think it was last decade, end of last decade, about 2019, 2020, somewhere around that, where, there was a DER application, somewhere out in the West. Basically, that is where we have a lot of wind farms, right? It's a network 34 kV circuit. There are a lot of wind farms that participate in the, transmission side market, basically. But now there was a distribution side DER that wanted to come on the 34 kV line. And, and that would cause transformer overloading, basically, right? So there would be, hours where we could not allow it to generate. And, in a firm interconnection world, you can either connect or you cannot connect, right? So that's basically the deal, right? And that gives the concept of flexible interconnection, right? Okay, in times when you see constraints, can you, manage the output of some of these DERs, right? And it still would be a very viable solution, right? So I think that is where we came up at about in 2019, 2020 timeframe. I think it went operational in 2021. So we actually have a, utility scale DERMS actually operational since 2021. We have collected 3-4 years worth of data. And it has about 7-8 megawatts already on it, right? We have another pipeline of having another about 20 megawatts. We're trying to bring it on about that 15 to 20 megawatt, right? Of other demonstrations. So this one was a use case that's called as thermal overloading of a station transformer, but we have other use cases as well that we can talk about. So that's how it came about, and there is no way we could have done it without a DERMS. It could not have been done in an ADMS. ADMS was not even at that maturity stage, right? Because it's such a bulk project that it doesn't give you that flexibility like when it's being built up. I am sure once ADMS gets built up and all the data is like coming into the ADMS platform, we will have some leeway to do these projects, these new use cases, nuanced use cases, but we are not there just yet. So that's how and why we needed DERMS to be there.
So was that at all a difficult business case to make to your regulators too? That, I know we fairly recently got approved for this ADMS and we're in the process of working on it, but hey, we also need this other piece of software that's sort of meant to be that next generation. And, I know that regulators in your state are also looking at what's happening in other markets and hearing that some ADMS projects aren't going so well for some utilities. So, and we're already advancing into this next generation of technology. So I'm interested in that aspect of the journey and in working with your regulators to make that case that you just laid out.
Yeah, that's a very interesting question. So I think the way our construct is that whenever DER goes to interconnect, right, and let's say there are, when we do our studies and then we figure out if it were to get connected, it would cause some adverse system impact, right? And there's a definition for adverse system impact, but let's say one of the definition or one of the adverse system impact could be overloading of an equipment, right? So whenever that happens, the mitigation techniques, the cost of the mitigation techniques would be borne by the DER customer, basically, right? So in this case, that cost was really high because you're talking about a station transformer, almost a new station transformer, right? So naturally, DERMS presents a lower cost solution, right? And the case that we made at the time was, hey, this is a demonstration, right? So it's not going to cost you like huge in that sense, right? It's a piece of technology that we would demonstrate. It will solve some of the customer needs. So I think we were able to connect, actually 4 customers are already on it, right? And we are working with the 5th customer right now for the demonstration. So the case that we made was that, hey, this is a demonstration. And this was what, 2020, around 2020, 2021, 4 years now. Because it was so successful, we were actually being asked by a lot of, our customers, other parties, stakeholders to actually do an expansion on this technology. That, hey, now that this has already worked, why don't you offer it at other locations that make sense? Right. So it was kind of the other way around where, we did the demonstration, but then now we were being asked to scale it up rather fast versus, waiting for something else. So I think the interest was really there. The economics was there. The use case was demonstrated. So in this particular scenario, it was not that of an issue in some sense, right? We were actually being asked for it.
And I'm going to ask you to explain flexible interconnection a little bit, because I think that's part of the value proposition of DERMS, especially in your use case. But it's one of those aspects of utility operations that, it's not lumped into grid enhancing technology, but it's kind of targeting a similar space of like, how do we make better use of what we've got? And it's one of the few pieces of technology within a utility that now the development IPP crowd, the asset owners, are saying, I want you to have a DERMS because I want the flexible interconnection.
Yes.
I want to be looked at as a dynamic asset that isn't just what's on the brochure from my OEM of the battery or the solar project, the inverters. So explain that a little bit. The move to dynamically looking at assets as real-time, functioning components of the grid and not just a static boilerplate of, load or generation.
Yeah. I'm going to go a little bit technical.
Go there. Because it can't be me.
Responding to this. And so the way I will do is with an example, right? Let's assume that you have a feeder, okay? And let's assume that feeder can hold up to 20 megawatt of load in either direction, right? So now let's say there are no DER present. Your concern is to study how much load would you put on that. So you would put at max 20 megawatt of load, right? And of course, your load would vary. Sometime it would go down to 10 megawatt and let's say peak is 20. Now you start adding DERs. So when we add DERs, we assume the scenario and let's assume that there is no load, right? Or minimum load. Let's say the minimum load was 10 megawatt, right? So the line could hold up to 30 megawatt, right? 2 megawatt of its 20 megawatt of its capacity and 10 megawatt of its load when you think about generation, right? But at certain times, it does go to 20 megawatt. So there are more capacity to be captured. You could, in theory, load it up to 40 megawatt or 20 megawatt of line, 40 megawatt, because 20 megawatt of load is there, it gets consumed, right? Either behind of meter generation or on the same supply. So this aspect of capturing the load dynamics and pairing it with generation is what we really call about, like, the if you had the flexibility in generation, you can pair it up. Now, you didn't have to build a new line, you didn't have to do anything. Just by the use of technology and utilizing the feature of your grid, the fact that load varies over time, you are able to connect more generation on it, right? Now, this is the concept of dynamic hosting capacity, right? There would be a firm hosting capacity, 20 megawatt period. Now, in this case, you're dynamically changing what you can host at any given time. Now, the flexible interconnection is just utilizing this whole phenomenon of dynamic hosting capacity, right? Now, flexible interconnection can be that, okay, let me analyze my grid, let me analyze, which month, what is the minimum load, right? And I make a statement that, hey, in January, the minimum load is only 10 megawatt, but in February, it rises up to 12 megawatt, right? So that gives me a 2 megawatt of extra generation that I could add. So this is something called as, in literature, you will call it like scheduled flexible interconnection or scheduled generation, right? But what it does is that it still doesn't utilize the maximum amount of dynamic hosting capacity that's available, right? And that is where, our approach, Comet's approach has been that, hey, we will do this in real time, right? If you really want to maximize the grid's, you know, ability, you really need to make it like as much real time as possible, right? So measure the constraint in real time and apply it in real time, right? And that maximizes the value for all your customer base, right? DER customer, they can generate more, they can get more revenue. The clean energy folks will get more clean energy utilizing similar resources. The customer will get better service as well. So I think that's the whole aspect of dynamic hosting capacity and flexible interconnection. So we are trying to utilize this whole dynamics, this whole aspect. It's not as hard in concept, to understand. It's pretty intuitive, but to apply it, to actually use it, there is a very heavy technological aspect involved, around it. So that's why we want to do demonstrations, basically.
Yeah, so let's talk about that a little bit. And that strategy for implementing. You put out an RFP, ended up going with AspenTech OSI for that DERMS. Would this be classified as a grid DERMS?
Well, the one that we did was for the demonstration, right?
Yeah.
So we did one demonstration, and now we are doing more demonstrations with the same vendor, basically, because we go out there and we say, hey, this is the use case. You're already here. Is this something that you can solve? And we work with our partners to figure it out, right? So this is the demonstration aspect of it. Once we go and do expansion, basically offering it for one and all, and that's something that we need to figure it out. And I think it's like a year and a half out, so I can't comment much on that.
Sure.
But expansion piece, when we come to that, we will figure it out. What is the use case? Who is best in business? What really works for our customer? What is the speed if you go with one, with two? What is the cost? And all those aspects of how you figure out, we'll have to funnel it down to get the right answer. But for demonstration purposes, that's how we went about, basically.
Yeah, and utilities are taking completely different approaches to this too. Some are going the enterprise route and saying, I want to go with one vendor and stack all the different modules from grid edge and aggregators of VPP stuff to grid ops to whatever else. Whereas others, I was speaking with Eversource very recently, they want a diversified approach. They want someone to be doing their managed charging, and they want someone else for thermostats, grid edge stuff, and someone else likely for grid ops down the line, and just kind of different ways of thinking there. So the strategy for implementation, would love to hear how that went and what you learned along the way, because we know with any software implementation, any tool you add to the deck, there are going to be hiccups, and working with your vendor partner to figure those out is important. But I do, and this is not a ComEd example. I do hear anecdotally all the time about challenges with DERMS implementation and challenges with ADMS. That these are investments of tens of millions of dollars, and if they don't work, then that's when some questions start being asked and some folks start coming under pressure. So I'm curious about that path for you guys and the strategy for rolling out the first demonstrations.
Yeah, I think one thing I'll say about ComEd is that we're really good at execution. So when it comes to things like this, we execute it really well. And I'll touch all the wood that I have. Just I don't want to jinx it. But luckily, this technology has worked really fine for us in terms of demonstration. We've not had any complaints from the customer that, hey, this is not reliable, or there has been hiccups, and I'm going to talk a little bit about those as well to your question. But so far, given this is like one first of its kind demonstration, right? Not a lot of people have done this really, right? In that grand sense, it has worked really fine. So once we started, of course, there were issues that the DERMS would lose communication with some of the customers, DER, right? But there are inbuilt feature where we would get an alarm that, hey, we can't communicate, right? So we'll go and we will look at it and we'll figure out, okay, what the issue is. So we'll fix that, for example, right? Then there are some sort of process issues that comes on that, hey, if the customer needs to do a maintenance, right, what is that issue, right? How do you communicate? Yes, something is written on the paper, the process and the procedure, but is it being followed in real time as people are working on this, right? So those kind of things really happen, have happened quite often. So we have figured those things out as well, right? Some of the other things is that we need to maintain the critical aspect of this technology to work is the communication between the customer-owned DERs and the utility side, right? For that, we need to have a really strong communication system, right? Be it on private LTE, fiber, or whatever it is. But at the same time, if the customer side, they don't have a backup power, right? In the event that something goes down, we lose communication. So we have to kind of drive the customer to set up those standards, because these guys are not like your typical generator operator always, right? It can be anybody. It can be, a store owner, for example, right? And they can have a solar, they decide to have a solar, but then they will have to get onto DERMS. So we'll have to kind of set standards there as well. And we don't know all the answers either, right? Some of these things we figure it out as we go. That's why demonstration is really important, because that gives you the chance of kind of pivot and make changes as you see fit, right? But the whole point is that at the end of the day, the technology should work, right? So that's there. I can foresee some of the issues that we will come in future. Right now, we are reading data, let's say from SCADA, but when it's cut over to ADMS, we'll have to cut over the reading of the data from ADMS, right? Sometimes ADMS and DERMS will share same equipment. They will read to the same equipment, right? So for example, a cab bank or whatever transformer, is it capable enough to sending data to two places? If not, what enhancement should we make around it, right? So those are kind of the things that we are anticipating, and we are trying to figure it out as we go. So I'm pretty sure you've heard of this, that we're trying to fly a plane while we build the plane, right? So
that is coming up in so many utility
yes,
conversations that I have.
It is. It's
a little frightening, Shikar.
Yes, it is. It has gotten really, really famous, and people are using it. So I've heard that from 5 different people already, right? But that's kind of true. That's why people say it often, that some of these things are there. At the same time, you'll have to also think about like the workforce management aspect of it, because these things, they require special skill sets, right? On the utility side, to understand these vendor technologies, to make sure that we are diagnosing the problem at the right time, because a lot of players out there are kind of new sort of startups. Not everybody is that huge conglomerate that you can rely on, like traditionally you're buying your transformers from, right? That's something that we are very cognizant of internally. So in my team, I've made it a point to make sure the technical know-how is there, right? I don't want to call the vendor first. I need to almost know what the problem is before I call the vendor for a solution, right? So I think we are trying to develop those things. So those are all learning aspects. So So I don't know if I answered your question 100%. We did have some hiccups, but we resolved them on the way. Nothing to an extent that, hey, that technology doesn't work. It's something that, okay, this is something new that we didn't think of. And that happens in every single technology that you put out there, right?
I do hear too that there's often a challenge here with utility people understanding how the grid works and their needs and kind of the day-to-day responsibilities of keeping everything going. And then the vendor community kind of, always trying to innovate and come at it from a technical or a technology innovation perspective. And sometimes there's a gap that exists there between, the software that's delivered to you guys and what you actually need to be successful in maintaining that, reliability aspect. Is that something that you have experienced along the way in working with some of these tools, and how do you combat that perspective divergence, I guess would be the way to frame it?
Yeah, I mean, definitely. I think that happens, and I think that will happen because it's really like two different parties talking two different languages at time, right? Because sometimes I will say, hey, I need an for example, I'll say I need an optimal power flow, right? Let's say if I use that term optimal power flow, right? It can mean different to somebody who has studied power systems in as part of their master's PhD studies, and it can really mean something else to somebody who's working in utility. Like, okay, optimal power flow means, okay, the power flow will be optimal, but it's a specific algorithm. If you go and check out the books, it's a specific algorithm that there is, right? So this is where there can be some sort of different understanding between your vendor and a utility. And this is just one example. There can be multiple of those, right? So it will happen, and it will keep happening as you try to build these technologies. Because think about an idea, right? When you come up with an idea, you don't have everything figured it out, right? Your whole point is that, hey, once we take this journey, we will figure things out along the way, right? But why it's complicated? Because there are not only two parties. There is not utility and customer only. Utility and vendor only. There's also customer. There's also like regulator. There are also other parties that are stakeholders in this whole process, in this transaction, basically in this collaboration, right? And that's what makes it a little bit more, you don't really want to fail or topple ever, right? But I think when you try something like this, there has to be a room for you to pivot and change, and if you do get down, get back up and whatnot. So it definitely does happen. I'm not gonna say it doesn't happen, but I think we figure it out as we go on this, right? So um and there will be multiple examples as we move forward, kind of the vision that we have of integrating DERMS and ADMS and all those things. There will be a lot of steps that we may miss, but nothing at a level where the technology won't work, right? That's my only thing. Like, the customers should not be sitting there and waiting for the technology, and that's the kind of approach that we have taken, right? That's why you hear flying the plane and while building it, that you want to deliver on the service.
Well, you don't want the vendor to be flying the plane and still building it at the same time. Like, you want that product to be fully baked, and I think that's been part of the challenge, is that that's evolving on the vendor side as well,
It is.
at least in the conversations that I have. And without speaking about Aspen Tech with the demonstrations, but the vendor pool more broadly. I mean, you went through the RFP process. Your thoughts on what the market is delivering to utilities today, and based on what you were looking for and ComEd's demands and your need for this stuff to work. Like, you're not just trying it to try it out. This needs to get out of sandbox and go to prime time. What would you say for the state of the market on the grid software side?
Yeah, I mean, when we tried it, I don't think there were as many players like 5 years ago now, right? But right now, I've looked at some of the terms. I think there is a report that goes out, right? There are like a lot more vendors out there, and
Oh, there's a
I don't.
lot.
Yeah,
There's
there
a
are.
lot. I think there's
And
a handful that have real DERMS products, and that's part of the reason for having this conversation. But there's a lot who say they have DERMS products.
yes, and again, because it's such a vague term, DER management system, you have the leeway to define what you mean by management system, right? So I'm not going to comment too much on how people market and sell their product. But
Oh,
if
you
I am
can.
evaluating, if I am
You're not going to get
evaluating,
in trouble for this.
if I am evaluating a vendor, right, I'm going to look for things that I think a DERM should have, right? And I can define those, right? For me, a DERM should be able to connect the customer DER, read and communicate with them, right? Connect with the utility data, utility sensors, and whatever that is, utility system, right? And solve a specific objective reliably every damn time, right? So to me, if somebody is trying to do that, they have DERMS, right? Now, why do I say DERMS? Because terms can have multiple use cases, right? Today, I may need them for a thermal overload use case. Tomorrow, it can turn into a voltage violation. Day after tomorrow, they may need to talk to an aggregator to participate in the energy market. This whole space is very, very evolving and complicated right now, right? So that's why I say DERMS. From a utility standpoint, I preferably would want a vendor to deliver on all of the solutions if possible, right? If they cannot, a pool of vendor, few, right, that can deliver on most of the solutions, basically, right? So, we don't purchase all our equipments from one vendor. We have the supplier diversity and whatnot, right? You've heard about the supply chain issues and all those things. One thing that I worry about is that because there are so many vendors out there, and John, I think you and I have talked about this a little bit, in our earlier conversation, right? There are so many vendors out there. People want to try this, but you don't want to try in a lab environment. You want to try it in a real environment involving real customers. What would happen if somebody decides to pack up their shop and leave, or they get acquired, right? And that's the thing that really
It's
worries me.
happening.
Yes, it would, and that's kind of my MBA side. That there would be a mergers and acquisition, some sort of consolidation in this space, right? Eventually, and what happens then? How do utilities keep providing the service that they provide? Because there is nothing that we can do really if the vendor side market is changing to some extent, right? So I hope that doesn't happen too often or too much, and we find out a way. But there are a lot of players out there who are offering DERMS, and it's really hard from checking out their website or whatever to tell which one will work and which one will not work. Because from experience, I'm telling you, it does take time and effort and real good skill set to make one work, right? At least that's what our experience is. So it didn't happen like out of the box; it just worked. We did lab testing for about 6 to 9 months
Wow.
or even more to make sure that it worked seamless. So it didn't work just out of the box. We really partnered with the vendor. We worked on our lab. We made sure that everything outside the customer's DER had a digital twin in our lab. So it was working as if like, you can take it out there and make sure that it works seamlessly. But before that, we did heavy testing on it.
I remember before Distributech 2024, Doug Hausman over at 1898, the consulting arm of Burns and McDonnell, posted something on LinkedIn that was like, here are the 50 things a full-fledged DERMS should be able to do. When walking the floor at Distributech or sitting in panel sessions, ask yourselves if the DERMS you're looking at or hearing about can do some of these things, all of these things, none of these things. So I do think that's an interesting conversation, and I'll move on from it because I get too much tunnel vision when it comes to sniffing out imposters. I find it fascinating.
You do
And
want it to work, right? So I think you're coming
yeah,
from a good place that, hey, these things should work. And I like Doug. I read his LinkedIn post most of the times, right?
oh, he
They're
brings it.
yeah,
Yeah, he'll like this shout out. Hopefully,
yeah,
who knows?
yeah,
Maybe not. Um,
yeah.
so, and we've already made it 40 minutes into this conversation. I haven't asked you for any data or performance on what the demonstration has bared out, but we'll get to that in a second. How often are you talking to peer utilities who are in a similar boat and working this out on the fly? And what are those conversations like? Are they calling you up and saying like, Shakar, I've hit a wall, or I don't know what to do with this, or how are you guys doing? I'm curious about the knowledge sharing there, because Distribute Tech other events too are great environments to share that. And there's some stuff you say in a panel. There's some stuff you don't. So I want to hear about the stuff you don't share at a panel.
The stuff that I don't share in panel, you want to hear it on a podcast?
Of course. Of course.
No, so from a benchmarking perspective, I think we do call out other utilities like directly that, hey, you're working on XYZ, and it's not just terms, every other topic. The utilities do talk amongst themselves, right? That's the first point. On DERMS topic, me personally, I've had conversations with utilities out there, out northeast, and some other places as well, talking about, okay, what's working for you, what's not working for you. We we do discuss vendors, but we do that less, because once you are like logged in. Now you're discussing that, okay, how do I make this work, right? So that's the switch that in conversation that we have, depending upon what time frame you are giving a call to the other utility. So right now, the conversations that I am having, I can loop you into those as a little bit, right? It's basically thinking of, okay, we have done the demonstration. Now when we are going to do the expansion, see, because for demonstration, it's different. You partner with someone, you are like, okay, let's just try to do this. If you are interested, this may or may not work. There's a common understanding on both sides. But when we are doing it as an expansion, as a program, everything should be processed, defined. Everybody should have the same understanding, right? And that could lead to some people having some expectation than the other, right? So how do we define that is a really, really hard task. I would say technical things, I think we can figure it out. But some of the process things, I mean, that's when you should start working early on it. And that is where, when we give calls to utility, we figure out, okay, this is the issue that we are anticipating. This is the solution that we are thinking. What are your thoughts on it? And sometimes they will say, hey, that's a very interesting thought. It hasn't come up. It may come up. But most of the time they're like, yeah, that came up in XYZ, and this is what we did, right? And I think you are on the same path, or, we did things differently than you. And we kind of bring that, and it doesn't stop just there, because we also then go ahead and work with our stakeholders and sometimes vendors, if that's the answer, and to say, hey, this is how it happened there. This is how it worked out. Can you make these changes, right? So that's the whole procedural aspect of it. So we are in constant touch with our peer utilities, basically.
I love this industry for that reason too. You're not in competition with each other, so you get to share those best practices. Like you want National Grid to improve their reliability. You want Southern Company to be able to innovate, or whoever it is, Dominion. I know you talk to Santosh fairly frequently, as most connected to the DERMS world. Talk to Santosh over at Dominion often, and he gets his shout out too.
I have to call him. We connected, and we used to work at NREL at the same time.
Yeah.
Now he's leaving with them, so after this I'm going to email him.
Okay, so let's talk about the demonstration itself. If you can parse out any data and quick wins that you found over the course of those few years, and what you hope to build off in demonstrating the value of DERMS on a full scale, enterprise is the wrong word, but beyond demonstration.
Yeah, I think I have some chart in front of me. So basically, when we went live in 2021, right? So I have like some data in front of me for 2022, right? I think like on an average, the number of events per month stayed below 4 or 5, right? So it was less than that. So meaning that every time you have a curtailment, you will lose 10 minutes of generation or something, right? 10 to 30 minutes before the constraint goes down and you bring them back up. But there were only like 17 curtailment event days in 2022 of 7 megawatt of DER. So that was not a lot of curtailment, meaning those 7 megawatt of DERs would not have been able to come online, if there was no DERMS. And look what happened. Only 17 events, and they're like not 17 days. They're like 17 small 30 minutes event, right? 10 minutes to 30 minutes event. That's nothing. That's like peanuts if you consider the whole amount of megawatt hour that we put on and clean megawatt hour that we put on, right? So from that standpoint, the performance of curtailment, like the need for curtailment itself, has been really, really low. And there has been times when DERMS is trying to send a curtailment signal, but it's actually not curtailing straight away. So we had to figure out the ramp rate, ramp up, ramp down, things of that nature. But that only happens when those unique edge cases presents themselves, right? So we kind of deal with that. But from a performance standpoint, it has been a phenomenal story, right? And we've shared this in our grid plan. We've shared this with our stakeholders. So it's an information that's out there in public. You should be able to look it up. But that's the reason why people are like, hey, this is such a success story. Why don't you do it at more places? So that's one point of data. This is the only DERMS that's operational right now. We're working on 2 other use cases.
The only DERMS within ComEd.
Yeah, within ComEd, yes. Within
Yeah.
ComEd, which is the substation overload use case, a thermal overload use case. But there is feeder overload use case that we are currently working on that will go live next year, right? And then there is a voltage management demonstration also that we are working on, which is a customer-owned microgrid. They want to sell energy and keep generating, for the energy market basically. And they are at a toe end of a feeder. We sometimes switch them to an alternative feeder. And when they go on an alternative feeder, it causes voltage violation, right? So now DERMS can help mitigate that by swapping the smart inverter curve in real time, depending upon the field values, right? So that's the third demonstration that we are working on. So once we are done with these three demonstrations, these are your most prominent use case, for PV related DERMS, basically. And in ComEd's territory, there are a lot of community solars. We have a lot of open land and whatnot, and a lot of solars are going there where load is low, right? So all the phenomenon, right, where the community solar goes. I'm not going to go much into it because I listened one of your, I believe, last week's report. Basically, you're like 3 guys discussing the phenomenon as well. So I know you're well aware of it.
This week in clean tech, a lot
Yes.
of just bluster in 15 minutes. But yeah, thank you for listening to that. I appreciate it.
Yes, it was pretty interesting. So so you guys were discussing the phenomenon, and that is causing a lot of constraints, right? And from utilities perspective, we want to connect as many DERs as possible, right? And wherever they decide to go, we don't take an approach that, hey, go here, go there. We have a hosting capacity map that guides them, that provides them all the information. But when application comes in, we study that on the merits of it, and we figure out, okay, where it can go, what is needed for it to go there. And that's where DERMS comes in.
Do you socialize those curtailment risks amongst multiple customers, or is that borne by the individual interconnecting customer? How does that work? And is it seen more as like a broader customer benefit instead of you agree to this curtailment risk and we'll ding you one by one?
Yeah, so I think, because the reason is that the way that the construct is right now, that any incoming DER customer has to pay for the upgrades that's needed, right? And DERMS is seen as a low cost solution. So if a curtailment happens, the customer bears the risk, right? Now, how does it happen and which customer bears the risk is a different question. You could do a last in, first out, meaning if you're the first customer, you will be curtailed last. Or you could do like a pro rata, which is like all equal curtailment. From a ComEd's or utility perspective, we really don't care much, right? We are like, okay, there's a system in place. Customers should agree on what works and what doesn't work. And that's where we have done the last in, first out when we did our demonstration. We are trying to do an equal curtailment demonstration as well, right? That's something that we will try. But at the end of the day, when we expand, how it will look like will really depend on setting up those rules. So we will do a workshop process. This is something that we propose at part of our grid planning process, that we really want to hear and work with our community solar and some of the developers, that okay, what works for you, what do you need, right? Because we want to develop a solution that works for the customers, right? So we have taken that approach. So more to be found out there and figured out there, which will happen like sometime next year. But that is where we are at.
How did you navigate the cost sharing for the system with the demonstration? And I guess you're thinking about that at more of a wide scale footprint as well. I know some utilities go the like digital solutions route where they have a division where, some of these bigger software tools or software as a service, subscriptions will hit, and it's more of a organizational expense instead of just your division on the DER side. You see that with private LTE from time to time, that a utility will be able to better justify that expense if it's distributed throughout the organization, because there are so many use cases and use cases that you don't even know of yet that are likely to pop up. How did you guys navigate that at ComEd?
Yeah, so I think for demonstration, I mean, we really wanted to prove out the technology, so that's a demonstration bucket. But this question is more applicable for the expansion piece, right? And that this is something that we are still working through, with our stakeholders and others basically on it. But the way I see this is that, there will be a base core technology that, you'll have to put it out there, right? Because, you have to first build the system. And that will have a cost that I anticipate, we'll have to, kind of socialize it, because, the DERs also provide benefits to our load customers, right? It's just not one way street, right? We get benefits of clean energy, environmental, and whatnot, right? So I think from that standpoint, but then the individual cost of a DER coming in will be again driven by the process. Now, what is exactly that process is something that we have to figure it out. Every utility can have a different approach to it, but it's at the end of the day, it's the whole thing of, hey, does everybody, all the parties, agree to this particular approach, right? So we have a proposal, but we'll still have to work through that workshop process to figure it all out, basically.
We've been talking about the benefits to customers or interconnecting DERs here, but what are some of the challenges in either you talked about the communication of the DERMS with the DER, but also customer education. Have there been any hiccups there in just getting that segment familiar with what you're trying to do and how it works and so on?
Oh yeah, of course. I've done, I don't know, countless workshops, man. Like I've talked for like at least 20 times on this topic to different customers, and it's not. Some of them get it straight away because they are probably in the space somehow, but a lot of them, the education is needed because it's new. It's new even for the utility folks. Even internally, a lot of education is needed. So it's not like very intuitive in that sense. And first of all, there used to be this whole stigma around, oh, utility having control over your asset, right? I think people have moved on from there now to some, at least for the bigger installation, right? That, okay, this is an algorithm, and you explain them the logic and they're kind of on board. They're like, hey, this makes economic sense for us, right? I think that's where people are on board. But of course, there is need for education. There has been need for education, and there is still need for education, because once we figure the process out, to explain out the process in itself will take time, right? And stay tuned to ComEd's effort. I think next year, early next year, we will be having more conversations around it, because we are going to expand real soon.
Save yourself the time. You don't need a workshop now. You can just send them this podcast, and that's my gift to you.
You can do that.
As we land the plane here, I know we're almost out of time, and you probably got to jump to something else. But I'm curious who else you are watching in the space, utility wise, as they're going through this journey themselves. And I know you guys were fairly early on, starting this in 2019. I'd put you right there with the Dominions and PG&E, and even National Grid announced an effort around that same timeline, but I think it took some time, a few years, for them to get to deployment stage on DERMS. What are you watching out in the field and hoping to learn?
But you name the usual suspects. I think those are the guys we kind of benchmark and talk to very often, right? But personally, I'm also watching the vendor side space as well. That's kind of very interesting to me if somebody comes up with something. And a lot of times our stakeholders, our customer themselves are like, hey, we have figured out this solution. We think it will work, right? People don't understand the complexity it takes for something to work. On the utility side, the cybersecurity aspect, we didn't touch a lot on it, but that's a huge aspect, and why we don't want to switch between 50 different vendors and whatnot. But I'll watch National Grid, Dominion, California in general, right? What's happening in the regulatory space there, the rulings that's coming out on there on flexible interconnections, things of that nature. So we do that. We do that a lot. But at the same time, we do also put a very large emphasis on talking to our own customers, our DER customers, and figuring what do they want, right? Because we don't want to just assume that if it worked for Northeast or California, it will work in Midwest, right? Things might be different. Phenomenon is different, right? So that's where we are at.
Just a closing thought on kind of the value of or the importance of DERMS and these advanced controls for the energy transition, and really, what you're looking forward to most in leading this team and supporting this effort. Because I know ComEd, you talked about the community solar growth. ComEd likes community solar and has been supportive of community solar and has advocated for some of these DER programs. So being, the linchpin for making that happen. Your thoughts on that overall evolution and the opportunity here?
Yeah, I think it's pretty exciting. Now, my thoughts would be that of course, we want to connect as many community solars as possible, or solar in general as possible, right? How do we connect them in a way that's sustainable for future? Because one of the things that you need to think about is that with energy efficiency and whatnot, the load may also go down, right? And what effect that will have now on DER generation in pockets, basically. Overall, load might go up, right? But in the pockets, it may go down. So some of those things, it's very interesting. So to me, the technical side is something that we can figure it out. To me, the policy side and the procedure side is what will be really, really interesting to figure it out, because that involves a lot of parties, a lot of people, right? Which is not driven by maths, right? So the math side, I am pretty confident about that we will figure it out.
Well, Shikhar, Pandey, it was great chatting with you about this. I feel like I could go for hours and was probably meandering quite a bit over the course of this hour. But thank you for doing this. And for those listening, I've shouted out Distributech a couple of times. Shikhar will be speaking at our next event in March in Dallas, and registration is open for that, so you can check it out. He'll be on the panel. 5 IOUs on the integration of DERMS, ADMS, VPPs, and microgrids for next generation distribution operations. That'll be a fun one. Shikhar, thanks so much for the time.
Thank you, John, for having me.